Hello and good morning. Let's see. Here we are. Oh, and here we are. I did a bit more reflecting, like conceptually yesterday. Oh, did I forget to tweet? We are live. And we are live. That's the first. I'm actually I tried to download. I need an Xbox game, something to play with, shoot some stuff. So I was trying to get that to start downloading, and then I lost track of time. Anyways, I've been reflecting a little bit on like what are these state machines, and one way I have been like conceptually reasoning about these state machines is how they work internally. Like when you specifically, how should I explain this? So imagine you have like two different states of the machine. You have like oh, wow, I'm zoomed out like crazy. There we go. So you have like two different states. You have like a foo state and a bar state. Yes, and what a state machine ensures is that whenever you are, well, we should really have one more state here. So let's say I also have a boss state. So what the state machine ensures is that whenever foo is active, it knows if you are able to transition to bar or boss. That's basically how it deals internally, and how it kind of protects you from suddenly moving into boss when you're not supposed to be able to do that. Like the machine has a knowledge of that. So when you interact with the machine from the outside, you could imagine like you're trying to move to foo, you're trying to move to bar, you're trying to move to boss. But the machine won't let you do that unless it's configured to do that. That's kind of like what state machines do. But there is another layer of state machines, actually, which was pretty much lost on me. Because as you saw when we started playing around with the API, we were explicitly trying to transition. But there is this other layer around the state machine. So if we imagine like in here, we have the transitions. But then we have this other layer, which are the events. So, and the way you can think about this is that this is the boundary of the machine. It's the events interface, and outside of it is the world. Anything can happen here. Like, stuff happens all the time. The user interacts, something happens in the browser, you get some data from the server, it doesn't matter. Like it's complete chaos in the outside world. And the outside world keeps pushing information into this machine. This happened, this happened, this happened, this happened. And you can see this in typical examples, like quite simple examples, but like mouse interactions. Like you're constantly moving your mouse, you're clicking or mouse down, mouse up, mouse move. Like these events are constantly being fired into the machine. Now, the point is that these events should be translated into a transition. So you don't expose the transitions directly to the outside world. You rather have this interface of events between the transitions and what's happening in the outside world. So for example, you will constantly get mouse move events, and then those events, like with some data, and then those events, the machine will try to transition into something based on its current it might be based on its current transition state. It tries to transition into a new state. I should have had like a better example here, but the point is this transitions layer, this is where the logic is. Okay, something happened in the outside world. What am I supposed to do with that? That's part of the machine. And that is why, for example, if you have an authentication machine, you wouldn't put like Firebase inside your state machine. That doesn't make any sense, because that's something that's happening on the outside. Like your authentication machine would deal with certain events like authenticated, authenticating, unauthenticated, whatever. And then the machine internally will transition into different states based on these events. And that is the logic. So like inside here, you have all the logic of the machine. Oh, anyways, you understand what I mean. So this is what I think about when we work with this API of Overmind now is, let's see, it's that we basically just want to tell the machine about what's happening in the outside world. That's the concept. And then we have implemented the logic to deal with these events inside the machine. As we can see here, this is the logic for dealing with events from the outside. What should happen inside the machine, right? And then we did the same here. By the way, I released a new version. Yes, and we did the same here. And then, let's see, auth, did we do the same here? Events, yeah, nice. Yeah, because we talked about like what should the name of these events be? And sometimes these names, the names are like it's events, something happened on the outside. So basically what this should be, it shouldn't be like set description, because that's like telling it what to do. You should say, just like we do with other events. So description changed, date changed. Yeah, like set error. Well, what was this related to? Okay. Rejected. Something like that. Active weekdays changed. Okay, so these are things that is happening in the outside world of the machine. And this should rather be like add rejected, something like that. Yeah, so let's change the name of these. Description changed. Active weekdays changed. Date changed. Add rejected. Cool. Yes, and then we'll do the same here. Page changed. That's actually what happened. Backlog updated. This is what happened. We got a message about the backlog being updated. And we got a message about days being updated. Yes. And then in our auth, we got a message about authenticating, authenticated, unauthenticated, invalid n. I don't know a good way to express that, but it's good enough. That's what happened. We got an event occurred that we have an invalid environment. And it just happens to map to exactly what this machine does. And I think that's typical for when you actually implement state machine specifically for your app. The outside events tends to reflect the internal transition states of the machine. Basically because you design the machine to reflect certain events in your app, right? So that makes sense. Then we have this one. Yeah, so this one isn't ready. Type events. Type. So what should we call this? I guess added. and, or what should we call this? Activated, deactivated, or like what actually happens on the outside here is there's a timeout or expired, for example. The notification is expired. Yeah. And the event here is that we added a notification. And then this should start complaining. Why aren't you complaining about the... That's kind of weird. Why isn't this complaining? Oh, sorry, events, there we go. So when we have something added, we actually get some data here. And that is a string, because it's the content of the thingy. And then we say content. Then we say state. Yeah, so the question is, do we allow adding a new notification? Like, should we, if we get 2 notifications while we're showing one, what should happen then? I think we will be, currently we will just override the current message. So we'll say current, and we have to make sure that this is, and content might be there, to do it like this. And then state content equals content, and then we'll return show. And then if expired, then we'll say, well, basically we'll just hide it, right? And if so the point here is that what we would do if we wanted to support multiple notifications is that we would have added, and we would push that content to an array. And then whenever we got expired, we would pull off that array, right? And if I think so. Yeah, how would we actually deal with that? Like, what's the responsibility of the machine? What's the responsibility of the outside world? Because in this concept, the state machines doesn't do any effects. So what happens on the outside is that it just gets notifications pushed in. That's what's happening in the outside world. And then the outside world also tells it to, no, I don't want this notification anymore. Yeah, so basically now, since it's only a single notification, we either show it or we hide it. But if we had like multiple notifications, we would rather have an array where we add and remove, right, from that array. So for example, it would be like an array where the latest notification would be at the bottom, depending on what you want, and then it would just basically pop those notifications or shift those notifications off whenever it got an expired event. So it wouldn't actually move into any explicit states. It would basically just deal with that array. Yes. And then you would, in your component, you would rather in your component, you would rather do like the transitions of kind of hiding them and stuff based on them being in the array or not. Like this could be completely automated. Like you have an array and you have some React component that fades out items from that array and stuff like that. Anyways, this is good for now. And then we can take a look at our actions again. So what's interesting now is that we are just going to, what, didn't I, does not exist. Oh, maybe I have to refresh. Maybe I have to refresh. Because I changed from transition to send. And the reason is when you deal with events, you typically do send, or you say like post message or something like that. While internally in the machine, that is where it actually does the transitions. So that's not, it doesn't make any sense to do transitions from the outside, because you basically just hammer the state machine with events. And then it's up to the state machine to deal with that. Let's see. Send. Why is it saying does not exist? Ah, I just fixed this. Did I miss something? God damn it. Match. Oh, it says transition. Maybe. Is there a newer version here? Oh, let me check. I must have messed up something. Oh, I was kind of preparing this. Let's see. Here it says send. Here I say send. What the hell? Okay, let me try to add it here as instead. It's sometimes it's the cache of npm. It's a little bit late on getting the latest versions, so it might just be that. So let's see now if it gets better. And we'll do, it should restart typing, but it might take a little bit of time. Anyways, so what it will do here is that we're going to say, we want to say that we are authenticated. And we're going to pass a user, a profile, and I think we want to create the app machine internally. But we'll take a look at that when the typing works. Come on, come on, come on, come on, come on, come on. Let's refresh. Or maybe, like, it did, maybe it didn't release. Let's see, maybe I got some error. It did. Oh, what the hell is all of this? Oh. Why did it go green when I have all these errors? That's weird. Oh, over my website? Anyways. Run test success. And it's running everything. So it's 6:30. That's the latest version. Let's see what we're getting here. Yeah, we are running on that now. Let's see, it's probably working now. No, is that got that. And now we have the type fetcher service is overloaded, so we can't. This is not a good day. This is not good. Let's try to refresh again just to verify that it's the type fetcher that's completely overloaded again. Package JSON. Let's see. Overmind. Yeah, here we have it. Status. Oops. Command failed. Oh, we can't get the typing. God damn it. Yeah, I'm a bit stressed out as well. Like we're having a baby in less than a month, and with all this corona stuff, like my girlfriend is stressing out quite a bit. Like we have some grandparents that's going to help us. Like we have a 4-year-old, so like what the hell do we do if our grandparents can't take care of our 4-year-old when we go to the hospital? What if I get sick and I can't be at the hospital? Like it's a pretty crazy thing to kind of push out a baby. You kind of want some support from loved ones. I can't imagine being alone at the hospital giving birth. That would be, yeah, that's traumatic, I would think. Anyways, yeah, so I'm kind of thinking about that next to everything else. But anyways, yeah, we can't really do anything about this. I think I'll just have to stop, and then I have to like scream again that we like. The problem is I don't know how to fix this. I have no experience with dealing with services. Like I have no idea how to connect to this type fetching service, and it's just not getting enough attention. Yeah. Yeah, I think I'll just book like an hour session today or something and bring in some other colleagues so that we can just get this stuff fixed, because we've been doing this for like several weeks now. And the thing, it only happens when you install like a new version of something, which is why we notice it so much, because we're constantly adding a new version of Overmind. So other people don't really notice it, but it does affect other users as well, that's for sure. So we have to get it fixed. Anyways, so yeah, so at least we can talk about, like we can try to kind of see how this would actually pan out. So we would transition into authenticated. We would just give the error message, and this would be typed correctly. And I don't think we want to give the app here, if I remember correctly, in our auth. We don't actually, yeah, we only pass the user and the profile, because when we're authenticated, this is where we say app equals create app machine. And then we import create app machine from the app. So that's done internally in the machine instead. And this doesn't have any arguments. So we'll just send invalid env, and we'll send an authenticated there. And here we'll send unauthenticated, and we'll just give it not logged in as an argument. Now the question is, what does this do to our like dealing with effects? So here we're kind of sending a message. So you could argue that like the proper way to deal with this, let's take this one. So what we're doing, we're basically just sending it, and then we will kind of have to check. Does the state, like, is the current state, did it actually move into authenticated, right? But this is just boilerplate. Like, typically you want to give an event, or wait, yeah, no, wait, yeah, so you kind of, yeah, exactly, because what you're sending here, in this case, it just happens to be the same, right? So you want to do it like this. You want to send authenticated, and then you get the machine back, and then you want to see, did we actually move into the actual authenticated state? So this is the event, and then we check, did we actually move into that state? Yeah, that's how you need to express it. And I think this is typed this way as well. Yeah, so this should always return the machine. Send, return. Has been disposed. Yeah, let's just return this. Okay, we need to fix that. And then we check if it matches, and if it matches, we can run some side effect. This does, of course, add some boilerplate as well. But it's conceptually more correct. Because we're sending an event, and then we check if it's it matches. And now we get errors on this because we're not returning the machine on send, but we're going to do that. Invalid. So what is nice about this is that sometimes we just want to send the event, and other times we don't want to do that. Which makes me think that no, I think it needs to be this way, because you might send an event that could end up in not multiple transition states, but could end up in one or the other transition state. So you want to match explicitly. So I was thinking, like, you could have like a callback here or something, but the point is it's not necessarily an explicit. Yeah, it doesn't really help you. You still have to explicitly say, oh, am I actually in this state now? Yeah, this is the way it has to work. And then if I'm unauthenticated, then we'll go and dispose the thing. So what might seem a little bit confusing here is that these two have the same name, but they are actually different things. So this is just the type of event we're passing in, while this is the actual transition state. So maybe it's a good idea to try to keep those as different. Yeah. I'm not sure how to name these things in a good way. You could say like user resolved. And then you check if you're authenticated. Yeah, we'll keep it like this for now. Let's do a couple more, see how it looks. Send authenticated. Authenticating, sorry. Then we'll go ahead and sign in. Yeah, and this is the thing, like where do we kind of, like, now we are protecting the effect. We are not telling the, so this is interesting. So in this case, we are not telling the machine what's happening on the outside. We are basically protecting our logic. So what should really happen here is we should just sign in, and then we should tell the machine, okay, we are authenticating now, right? We're just telling the machine. And if for some reason the machine is not in a state where it can move into authenticating, it won't do that. Yeah, so this is what I'm wondering. Like, should we just tell... I wonder how that would work. Like, I like the concept of doing that. So basically what we're doing is, okay, hey, I got the user, I got the profile, let's fire up these effects and let's tell the machine that we're authenticated. And if for some reason that is not the case, like it can't be authenticated, maybe it's already authenticated and you don't allow it to be like re-authenticated, then like nothing happens to the state. The effect will still run though. And that's kind of the, I guess that's the problem. You would get into these weird bug scenarios where, yeah, how would this work? I'm having a really hard time like putting like this pure idea in my head of how this should work. Because on one side, like looking at this thing, you kind of just want to pass events in like crazy. Like all this stuff is happening. But here we are creating conditional logic for making things happen in the outside world, which is kind of the opposite. So what would happen here is that if for some reason I got authenticated twice, nothing would happen in the machine. But I would still stream the data from the other profile. So whenever I got like an update on the backlog, I would get the backlog items of the other user. Right? That's not what I want. I want to ensure that whenever we start streaming a backlog, it's actually for the authenticated user. So I do want to protect those effects from running by ensuring that we actually did transition. But yeah, it's interesting. Yeah, it's very interesting. It's interesting. Yeah, I have to reflect on it. And then we would send page changed to home. Did we? Oh yeah. So when we go to add backlog item. We actually want to add this thing. We have to ensure that in this page changed thingy. The thing I think I'm also stressing a lot with is that this is blocking the next Overmind release. And I just don't see any end to this. Like every time we iterate on it, we do something different. And it's taken like, maybe it has postponed the release maybe like 3 weeks or something now. And at the beginning, I really enjoyed iterating this, but now, yeah, it's starting to stress me out. And with all the other stuff I talked about, it's really stressing me out. So send, okay, I'll do this final thing and then add backlog item, no, sorry, page changed. And then this is going to happen inside our machine instead. Up. Yeah, so this one is a little bit, it's only the add backlog item that behaves differently. Maybe page changed was a little bit too generic because they do behave differently. So we should maybe have had specific events for each page. So like home, like home, like it's not necessarily clicked, but home navigated or something like that. Sometimes having these consistent ways of expressing things can feel super awkward. So like moving to the home page, what does that actually mean in terms of past tense? Like page changed makes a ton of sense, but home navigated feels a bit weird. Home clicked. We don't know if it's clicked or touched or whatever, so that's kind of too specific. But anyways, if page, if state current home, yeah. Yeah, I think we need specific events for each page so that we can properly deal with it. Because home is different, add backlog item is different. These two happens to be the same, but yeah. So home navigated. If you go to home, then we'll always move to home, and then we have backlog item navigated would be. Here we actually want to set the state to add backlog item. Yeah, given that we are, if the current equals home, then we want to do it. Return add backlog item. And then we have, what was the other one? Plan next week navigated. And again, if we are on the home page, that's when we want to do it. Return plan next week navigated. You could say like triggered or something like that as well, but yeah, doesn't matter. And this is plan current week, edit current week. Cool. And then we need to remove this. We're not passing in that. We're saying home navigated. And we're saying a backlog item navigated. Then we're saying plan next week navigated. And then we're saying edit current week navigated. Cool. Maybe I have some typos there, but yeah, we'll get that typing back for our next session. And I might be working on this in between this weekend, because I kind of have to, I can't scope this just to our stream, because this needs to get done. And I'll rather show the result of it during the stream. And then we'll see what we'll do about it. Let's see, this should have state, this should have state. Yes. And then these ones doesn't do anything other than that. And then this will be navigated, send. Oh, do I have a meeting now? Let's see, calendar. Yeah, I do. Yeah. Okay, I have to go. Yes, I'll have some more energy next time, hopefully. And hopefully we'll get this thing finally done. But like what I explained here in the drawing, this is what state machines should do. You should just be able to hammer them with events happening, and it eternally manage controlling the state. So that when you consume it, the machine on the other end, you are just sure that whatever you consume is correct. So you're kind of hiding the world, a complex world behind a very concrete, manageable thing to consume, which is the state machine. So you can imagine like insanely complex drag and drop interactions being the world. And then the machine is what makes it possible for you to handle all these events in a consistent, straightforward way. That's kind of the thing. Yes. Cool. Bye for now. Talk later. Finish.